Hello everyone, my name is Devin Alumcia, and I'm part of SDMA 2533. And so this video will be covering some randomization techniques, covering the multiplexer drawing inside of PrairieLearn. And so we have this documentation, and hopefully it's helpful to start figuring out what the implementation should look like, what it used to look like, and how to achieve the desired implementation. But also hopefully this video helps to give a better visual of it. So looking at the previous implementation of multiplexers inside of some of the questions of PrairieLearn, right here, this was the old implementation of homework 1, question 3C. And so you can't tell in this, but this is just a picture. It's not something that was drawn by any of the PrairieLearn tools, but it's just a picture. And so how it previously was they had multiple pictures of different multiplexers. And with these pictures, they just randomized which ones were displayed to the students. And so now what we're looking for is, this also still looks like a picture, but this is actually a drawing. And so what we're looking for is for the multiplexer that is displayed to students to be randomized and completely all drawn with PrairieLearn tools. So with this, we're going to use PL drawing as our tool. And inside of it, there'll be some different elements to achieve this desired look. And so the benefits of this being a drawing over just a picture that is randomized, randomly selected and displayed to students, and this being a randomized drawing, is so that it's more scalable. So if we want to add a larger number of inputs, that would be perfect for a drawing. If we want to change this up in any way, change the size of the multiplexer, change the number of inputs, change number of select bits, and actually have them going in instead of asking the question for how many, or what is the minimum number of select bits required or needed. If we want to change anything about this picture, we can go in and change the randomization of it so that it fits the implementation of a question. So, like I said, we're going to use PL drawing. And so now we look over at the code of this question. We'll get these pulled up. With the code of this question, you can come in here and you can see that we are using PL drawing. And so this width and height, what this is doing is setting the size of this box. And this grid size just shows that this will be white. Now if I were to change this and say grid size is 1, then this would change and you would see some grayness. Let me change this up. The grids are probably too small, so that's why it seems gray. Oh, yeah, there you go. So then you see grids. But for this implementation, and for most PrairieLearn, or for most multiplexer implementations, you're just going to want 0. So now we go back to this documentation. This will show you the question.html file for this question, and it'll also show you the server.py, which is where we randomize some of our inputs. And so inside of the actual drawing and making of the multiplexer, we have PL polygon, which is the first element that we'll take a look at. So this is an example code snippet, but we'll actually just go to the code here. So this is what will actually make the multiplexer. Now if you see in here, there are 4 x values and 4 y values. These y values are going to be pulled in from our server.py file, which I'll get into in a little bit. But as you can see, we have our x values set in stone. So that means that x for this point will always be, I believe it's 350. And then x for this point is always 400, always 400, always 350. So now you can see if we change it. So if I were to change this to 300 instead of 350, this looks completely different, which makes sense because we are changing the X value. So that's the biggest thing with this stuff, is that a lot of the value pairs, the XY pairs, it's just going to take a lot of trial and error and seeing what you need and what you want your multiplexer to look like. Now with these Y values, these are ever changing because the size of our multiplexer is always going to be different. And so now what I did was I was given the range from anywhere from 3 to 12 inputs that we wanted to test with. So if I have 12 inputs, we're gonna have a bigger multiplexer than if I had 3 inputs. But so what happens here is we have our Y values set. So if there's only 3 inputs that are being used, then this is going to be the size of our mux. This will be the size, this will be the placement of the Y values. But if it's 12, then we're going to have a much bigger multiplexer, so that needs to change. And so that's just where the Y values come from, is it's completely randomized based off of the random selection of how many inputs we have. And so that's what the PL polygon element is. And now we can go to the next one, PL line. PL line sounds just like its name. It's just drawing a line. And so we have the XY pairs from one point of the line to the other point of the line, and the line is just drawn in between where these points are. So right now, PL line, the only element with PL line in here is this one right here. It's not an arrow, just a line. So if I were to change the first point, it's going to be different. It's going to be just an even line. But we want this to be a little bit of a slash. So that's what we do. Boom. All right. So there's not much to the PL line element. But now we move on to the PL vector. So PL vector is used to make an arrow. So we have the PL vector here. So this arrow will be the one that is found pointing down. It's our select bit arrow. And so we have a few different attributes inside of this element. So we have an XY pair. So that XY pair will be where the anchor of the arrow is. So the anchor will be right there. So that's what our XY pair does. And then this width, we can change it. See, this width, it just is the length of the arrow. So we just changed our length from 50 to 100, so we just doubled it in size. But I'm going to put this back. Now the angle is what direction the arrow is pointing. So 90 is actually down. We'll see that 0 will point it to the right. And then 180 will point it to the left. And then 270 up. And I'll show that here. 270 is up. But we want it pointing down, so we have it as 90 for this arrow. And now you can change arrowhead length, and that does what you think it would. It just makes the arrowhead longer, bigger if you increase it in size, or smaller if you decrease it in size. And then we have the stroke width, which is basically just how big or bold or wide the arrow is. And then lastly, we have color. So with a lot of this randomization, with a lot of these arrows, so we see this PL vector even down here. So it has the parameter of color. It is pulling color in from the randomized values in the server.py file. And so we'll always have at least three inputs. We know that for this question. It could be different for a different question. We'll always have 3, so these will always be black. But if we only have 3, we want these to not show. But just due to randomization, they have to be there We just have to make them invisible. And so when there's only 3, we set the rest of them to white. That way, you don't see them. But they're there. They're just white. You don't see them with the background. So this was how many inputs? We have 5 inputs here. So if we go to 5, we see that the first 3 from here will be black. And then the next 2 also black, so that's 5. The rest are white, so they're hidden. And so that's kind of how some randomization works with finding the arrows. But basically, the color just changes, obviously, what the color of the arrow is. So if this is red, we have a red arrow. But we'll keep it as black for now. So that's the PL vector element inside of PL drawing. And now, I believe the last element used to make this multiplexer is PL text. PL text, exactly what you think it would be, is just text that can be put in. So we wanted to number our inputs. We wanted to put select bits. We wanted to put this question mark to ask how many select bits are coming in. And so PL text, we can use this one as our frame of reference. So it has a XY pair, which is just where the text will be placed. Then the label is what the text is. The latex element just changes some font. So if I change it from this to latex, it just looks a little bit different. But I think I prefer false. I prefer not latex. And then font size is just the size of your text. So it's all fairly straightforward, but hopefully this gives you a better idea of different elements inside of PL drawing and how they can be used to create a multiplexer. Now, as far as the randomization goes, we can look in server.py, our server.py file. And so how this goes is I randomly get a number between 3 and 12 because that was the range of inputs that our advisor had wanted us to do. And so it's kind of tedious, but you have all these parameters, all these numbers. And so what this is doing is, there's a number. This is number, I believe, in server.py. It starts with number 4 because there's always going to be 3. It's 1, 2, 3, 4, 5, 6, 7, and so on, right? And so what this is doing here is because we have 10 inputs, we're going to get 10 numbers. We're going to get a bigger mux. We're going to get a different, because the mux is bigger, we're going to have a different XY pair here for this arrow, this output arrow, compared to if it was smaller. And so these first 4 are for the mux itself. This last one is for the output arrow. These colors are for the PL vectors, which is just our arrows. So we want all the rest of the arrows that are made to be hidden because we only have 3. We don't want any other text to be displayed, so we set the value of label, which is the parameter here, the value of label as nothing, so nothing shows. And then we have our correct answer, which is for the auto grading. So we see that we have 10 select bits, and so we see with 10 select bits, 10 inputs, sorry. So we see that our select bits should be 4. So we can go in and we can put our answer in. And I think I have to put a random answer for these as well, just for it to be graded. And voila, that was correct. So the auto grading is also taken into account here because we see in the questions.html where it asks this question, the answer is just this int value, which is what our correct answer will be. So that is just how some of the randomization and auto grading works behind this question. And that is also how a lot of the drawing is done with PL drawing and the different elements inside of it. So Thank you so much for watching this, and hopefully you get a better feel for everything. Thank you. Bye.